Hello everyone, welcome to today's lesson. Today's lesson will be brief because it's just an introduction to the ETAP software and the interface, just to get you to know about different parts of the software. Now, the first thing I want to say is this is what the software looks like. Now, this part of the software from here down or here is called the system toolbar, which comprises of different parts. Now, this first one is the system manager, which is this, which shows the total components available. Then this is a one-line diagram, which gives rise to this free space for designing in a one-line view. And then these are other modes: star systems, star Z systems, underground raceway systems, depending on the design you want to do. So, having explained here, then this is your dumpster, whereby any deleted element you have removed from here goes to the dumpster, and you can still retrieve it until you delete it from the dumpster. So these are your wizards. This is your study wizard, this is your scenario wizard, this is your scenario wizard, this is your study wizard, and this is your project wizard. I will get to explain the functions of these wizards later on as we progress. I won't really digress into explaining everything in detail now, because if I do that, you'll still end up being confused. So the pattern I'm going to use is by explaining a particular mode and then giving examples to make you understand the actual function of that. So, having said that, we move to this. This is called the mode toolbar. This consists of different modes, and the first one here is the edit mode, which gives rise to this, everything here. So this part now are for AC elements, while this is DC. These are DC elements and these are AC elements. In the edit mode, we have the opportunity to bring out elements and design our one-line diagram. Remember, we are here for one-line diagrams. So moving on to this is load flow. This is for load flow analysis. Now if we come here, we see that the icons have changed. We can no longer bring in components. Anytime we want to bring in a component, we have to come back to the edit mode, and there we can change elements, bring in new ones, change parameters, and so on. Then this is the short circuit analysis. This is arc flash analysis. Same thing with every other mode. Now let me give you this ideology with load flow, and then we apply it to every other thing. On load flow now, this is to run the load flow calculation. This is what you click. This is for auto run or off. That is, whenever you change a parameter, it should just automatically run the load flow. Then this is to halt the current calculation. That is to stop the process of the load flow. And this is your report. This is your alert view. Whenever a system is in over voltage, under voltage, or overload or underload, that pops up the alert. So basically, these are the units. This will show the unit you need, but we'll get to understand all this as we digress into this lesson. So now, this is your data manager. I will show you the function of this later on. This OLV means one line view. So this is the one line view of this page we are in now. This part, okay, let's go back to our edit mode. Now this part is to create a new document. That is to create a new file for your design, while this is to open an existing document. Let's say you were working on a project before and then you saved it, and later on you want to open the project again. You can come here to this icon and open it. Another way to do that is by coming here and clicking here. You can see new project, open project. So next, this is the save icon, this is to print, and this is to print preview. That's to see what you're about to print. Now moving up, this is your file. I've explained this. Here you can see new project, open project, close project, and all that. And this is your editing. To undo, redo, select, insert new object. And this is your view, which is for zooming in, zooming out, although these functions are still available in other places. And this project, now from this project you can actually change the standards. When I say standards, I mean you can change the frequency of the system from 50 Hz to 60 Hz or whatever you want to use. Now basically there are two, ANSI and IEC. Let me see, yes, ANSI and IEC, the standard. ANSI now operates with a frequency of 60 Hz, while if you're going to use IEC, it's going to operate with a frequency of 50 Hz. And now if I change this to 50 Hz, you observe this, watch. The components are still the same components, but the icons have changed. Okay, let's take this for example. Note this power grid. Watch this, see the icon is rectangular, right? Now let's change it back to 60 Hz to ANSI. See the same power grid. It's now more of an upside down triangle. So basically it's just to change the frequency of the system. That's just that. And then moving over to this is pan, this is to zoom in, and this to zoom out. This is to zoom to fit page. Now this is for the grid lines. Let me turn it on. These lines we are seeing with small boxes, but I prefer turning it off. Depends on your preference. It doesn't actually change anything. While this is for the color, you can change it to black, or you can leave it at default, or any setting you want to give it. So basically that's for the interface of ETAP. Now I'm going to drop a small example for us. Now the aim of this example is simply to get you familiar with ETAP, basically on how to drag and drop components, and also how to join components together in one line diagram. So we are going to start by doing a simple project, which is joining the power grid to a bus, and then a transformer. Now this is a transformer, a 2-winding transformer. This is a 2-winding transformer, while this is a 3-winding transformer. So basically at the beginning you won't be familiar with these components, but with time you get to know them, because once you take your cursor to a component, it will actually show you the name of the component. So a 2-winding transformer, and then a lump load. This is a lump load. Okay, there should be a bus in between this transformer and the lump load. Now when I say lump load simply means combination of 2 or more loads. Now your load could be your lighting point, your sockets, and all that. So basically, connecting these elements, it's quite easy. All you have to do is take your cursor to the element and find a pink spot. Yeah, this one right here, and you click on it and drag to the next element you want to connect it, until, if you notice this bus now, bus 1, it's black, but then when I drag the cursor to it, it turns pink, which means it can connect, and you leave it and it's connected. Then you come to the transformer. Remember our pink spot, we find it. Okay, we connect the top of the transformer to the bus. The bus is pink now, so we can leave it and it's connected. And then we connect the down of the transformer to the second bus. The bus is pink, so we can leave it. And then you can just adjust this bus. We connect the lump load to the bus. It's pink, so we can leave it. Now, another thing I want to show you is that you can extend. Okay, that will be in the next tutorial. But then, now parameters, setting up parameters. For this utility, the power grid, you double click on it and then this dialog box pops up and you can see different icons. Now for the rating, the rated kV, this rated kV will be the rated kV of the bus it is connected to, the bus bar. Then for the short circuit, let's use about 1,250, and then we click OK. Now remember, if you look here now, bus 1 is 0 kV. Remember here it's still 0 kV, but when we come to bus 1 and give it a nominal kV of 13.8, let's go with that. Now bus 1 has a kV of 13.8. Now let's come back to the utility grid. The kV is now 13.8. 13.8 is now the rated kV, which means the rated kV has to be that of the bus bar it is connected to. Now coming down to the transformer, the rating of the transformer. Watch now, this primary of the transformer is connected to bus 1, and bus 1 initially has a rating of 13.8 kV, and that is why it is here, primary bus 1, 13.8 kV already. Then let's go to the main rating of the transformer, MVA, as the power, apparent power. Let's say about 20 MVA. And let's go to the impedance. If you notice here, the secondary is 0. That's because the bus it is connected to from beneath, I have not actually put the nominal kV. Once we put it, it will reflect here. Now, when we go to impedance, percent impedance, let's use about 6% impedance. Then XR ratio of the transformer should be, let's say, 17. So I think sorry, that should be all for this for now. Then bus 2 rating for the nominal kV, let's use 4.16. Sorry, 4.16. Now let's go back to this transformer. See the bus 2 currently 4.16. So we're on the right track. Now for the lumped load, the rating on the nameplate, the MVA, let's say 5. and then percent power factor, let's say 80%. Then constant kVA, let's say 70 for the load type. And then okay, now basically we have a simple one-line system. Now I'm going to show you another way to design this, a much easier way actually, the same system. Now there was an icon I didn't tell you about during the explanation of the interface, which is this. It's called the Line Autobuild. Once activated, now it's activated, we can get the power grid and drop. Now we select the power grid. If you notice, some components here got dark, some are darker. I've removed the selection, so now these are all the components. Watch carefully. Once I select it, I can no longer select some other components. Why? Because a utility grid cannot connect to it. These are the components that can actually connect to the utility grid. So, which makes it easier for you to know what can connect to what. Now remember, we are connecting a power grid to a bus bar. Once I click on the bus bar, it will automatically connect due to the Line Autobuild, like this, automatic connection. Now the bus is selected and we are supposed to connect it to a transformer. Once I click on the 2-winding transformer, it's automatically connected, and then the transformer is connected to another bus. I click on the bus, it's connected, and then the bus is connected to a lump load. I click on the lump load and everything is automatically connected, and I'm done already. So basically the purpose of this lesson is to get you familiar with components and how to connect them, and hopefully try out this example, send your reports to me and I'll check them out. See you in our next lesson. Thank you.